Hello everyone, we are solving triplet sum in array problem. So we have given an array of integers and an integer x, and we need to find if there exists any triplet in given array which has a sum equal to the given integer x. So in this case we will check. We need to find x is equal to 13, which is sum. So we do have 1, 4 and 8 which sums up to 13. So in this case output is gonna be true. Then in the next case we need to find sum equal to 10. So we do have 1, 3 and 6. So in this case as well output is gonna be true. But I will give you one more example. So let's say we need to find 35. So we don't have any triplet inside array which will form sum up to 35. So in this case output is gonna be false. So there are multiple ways of solving this problem. What we can do is we can just nest 3 loops and check all possibilities of forming triplets, and we will just check some of them equal to x, and if we find any possible combination of triplet which is forming sum equal to x, then we will just return true, else if we came at the end of loop we will just return false, but it will take time complexity of O of n cube. But they have given that expected term complexity is of n square, so we need to find better way to solve this problem. So what we can do is we will just sort this array. So I will explain you through this example what we are going to do. So sorted array is going to look like 1 and 4, then 6, 8, 10 and 45, and x is 15 which is given. So I will just remove given array. So now what we have to find? So we do have a sorted array, so that means we have track of largest and smallest elements. So we will place one pointer here I, then we will place one pointer here k, and we will place the last pointer on the uh, index of k minus 1, so which is going to be travel from the next index of last pointer backwards, and one pointer is going to travel from 0th index to uh, the index of largest pointer. So here we will check if, here we will just take our sum. So in this case sum is 1 plus 10 11 plus 45, which is 56. So this sum is greater than our given sum. So what we can do is we will just decrease this pointer j. So we will place j here. Sorry. Okay, so now we have j at 8, and I, we are going to run I from 0 itself, and k is gonna run through a loop. So in this traversal we are at index I, length minus 1, which is the last index. So now we will check the sum. So 1 plus 8 plus 45, which is still greater than 15. So our current sum is 54. Now as our sum is greater than our current or the target element, so we will just decrease the second pointer to here j. Okay, now our j is pointing at 6. So our current sum is 6 plus 1 7, then plus 41, which is equal to plus 45, which is equal to 52. So we will check all these cases till I is less than j, but we won't find any sum in this traversal as 45 itself is bigger than our target element. So we will shift our pointer k. I will just write first I here. So we will run I from here, then we will have j here and k here. So now we will check if our sum is equal to target, or if not we will just move our pointers. So in this case sum is 1 plus 8 plus 10, which is 19. So So again we have sum more than we needed. So what we can do is we will just x is 13. Okay, I will just update it. Yeah. So now in this case our sum is greater, so we will just move our j pointer to the left, and k is gonna add 10 as well till our traversal completed. So now in this case our sum is 1 plus 6 plus 10, which is 17. Again our sum is greater than our target sum, so we will just decrease j pointer by 1, and k is gonna be at 10 itself. So now in this case we will check if our sum is equal to target. So in this case our sum is 15, 1 plus 4 plus 10. Again it is greater than our target element, but we have reached to a end of loop, as in the if we decrease j furthermore, we will get I is equal to j, but we need to distinguish 3 pointers. So we will make a condition that I should be I should not equal to I should be not equal to j. Okay, so now in the next case, again now j will be at 6 and k will be at 8. So now we will check the sum is gonna be 1 plus 6 plus 8, so which is 15 again. So and it is greater than 13, so we will just move our j pointer to the left. So j pointer is gonna be here, and k is gonna be at 8 itself till our traversal completed. So in this case our sum is 1 plus 4 plus 8, which is 13. So we get our sum which is equal to target sum. So in this case we will just return true. But in this example we haven't moved our I pointer, as we didn't get any case where our current sum is less than our target sum. So if we get sum less than our target element, we will increase our I pointer by 1. So we will just write the code. For that I will write here approach sort an array and place 3 pointers. So time complexity is gonna be of n square, as we are running one more loop using I and j again inside a for loop of k. So what we can do is first we need to just sort the array dot sort a, then we will just run a for loop, and we are going to run a for loop from the end, as we have run for k. So in this I will just name the same variable. So from n minus 1 till k is greater than equal to 0 and k minus minus, but instead of 0 it should be 2, as triplet size is not gonna be lesser than 3, as I and j should at least have index numbers 0 and 1, and from 2 k can be at anywhere. So for this we will make this change. I will declare 2 variables, I from 0 and j is equal to k minus 1. So we will check. So let's make one variable, print sum is equal to, so before that we need to make one while loop as well for increasing and decreasing our pointers and checking some simultaneously. So here I will just make one variable called as sum a of I plus a of j, which will contain sum of our triplet. Okay, and we will check if sum is equal to x, we will just return true, as we got our answer. Else if our sum is greater than x, so in the case we discussed, as if we have sum greater than or target sum, so we will just decrease our j pointer by 1 in the left, j minus 1. Else if we got sum less than target element, so we need to increase our the leftmost pointer, as it is pointing to the smallest element, so we will increase it by 1 in this case. and if we run a loop and didn't find any answer, so in this case we will just return false. So let's try to run this code. Okay, it's running. Let's try to submit it. Why they are not reading here? Now it is processing. Okay, so I hope you understand. What we have done is we have just placed 3 pointers, one at the end, then second one is next to the last pointer from to the left, and one from the beginning, as we need to keep track of smallest and largest element as well at the same time. So in any at any position we get sum equal to our target element. In this case we are just returning true, as we don't need to find the next combination, as we have already get our answer. But if in any case our answer is or our triplet sum is less than the target element, so in that case we will just increase our I pointer, as it is pointing to the smallest element, so we will increase that element to the bigger one. And if in any case our target sum is less than our or greater than our target element, the triplet sum, so in that case we need to decrease that sum, so we will just decrease j pointer by 1, as it will move to the element which is smaller than the current element. So, and we have solved it in O of n square time complexity and O of 1 space complexity. So thank you.